physics, mechanics, and we are on now lesson 14. Okay. Right, it's opening. Oh, come on. Okay, so, whoops, why did it jump to the middle? Okay, if you want to write this down. Cantilevers and further support. Oh, hang on. Well, the reason I put this here is because I want to delete my last question. And also...
Okay. This is talking about the mechanics? Displacement?
Hold on, I also want to delete the word try. Since that caused a problem.
No, C-I-L-I-E.
Yeah, okay. Let me delete that. And the boy pushes his father. Okay, now it's better. Right, did you write that down? This is the title. Cantilevers and further support. Yeah.
This is the lesson for mechanics?
We're still doing mechanics, yeah. We'll probably do mechanics up until the midterm break.
Oh.
Mechanics is the biggest part of the course.
You mean that's the hardest one?
Yep, also the first one. Okay, you got the title?
Yeah.
Yep. Okay, so we're going to continue with turning force. A very common problem is this. This is very common. Yeah. So what's happening here with the steering wheel is that one force goes up and one force goes down, and they're equal. The same when you're on your bicycle. We have one force here and one force here, and again, they're equal. So this is a special type of problem. And this type of problem where they're equal and opposite, this is called, did I not write? Yeah, well I wrote the name up here. It's called a couple.
Couple means both.
Means two together, equal and opposite. So, just to be clear, let me draw that for you. What you have is something like this. This is D. Well, we'll say the total is D. So this will be D over 2, and this one here will be D over 2. And then what you have is a force here, and the force here. Now, clockwise or anti-clockwise, if this is the turning point?
It will be, I think...
Anti. And this one?
Clockwise.
No, anti. So they both work together. Yeah, they both work together. So, what's the turning force for this one? D over 2 multiply F. And then this one? D over 2 multiply F. So the total is D multiply F. The diameter multiplied by the force.
But the two were have gone. D over 2 times.
They add together to make 1D. So just to be extra clear, what you have here is a half df plus a half df equals 1 df. So this is what's called a couple. You have two forces, they're equal, they're opposite, and they're the same distance from the turning point. It's a very common problem in physics. So, you know, whenever you have something that you're turning, or the steering wheel, or the bicycle, these are all couples. Okay. So if you can write this down, please. Yeah?
The definition? I finished.
You have it already?
No.
What? Huh?
We haven't written a definition yet.
Oh, I know, but I want this is like the proof of this simple formula.
I wrote the definition.
That's fine, but I also want this formula.
Like I wrote the line.
Which one?
definition.
No, I haven't done the definition yet. I just want this diagram.
Yeah.
The thing is that
Okay.
the definition.
We'll get the definition, don't worry. So couples, they only make a turn. It won't go up, it won't go down. This will only turn.
Yes.
So I really just need this formula.
I wrote.
Good, okay.
But it's annoying, like when you turn the steering wheel for the car and like it comes the opposite way, not the way that you want.
So you turn the steering wheel left, but you want to go right, is
Yes.
it? Or
Yes.
yes. That would be a problem.
That would be really annoying.
No, it would be. All right, continue. Okay. So now the definition. So the definition is a couple is two equal but opposite forces
Yes.
that are a distance d and cause an object to rotate but not move linearly. And the total turning force is Fd.
But previously it was also the same D and FD.
Yeah, but it seems a bit interesting now because the F is twice in the system and the D is not the distance to the turning point, it's the distance between the two forces. In other words, Mir, it's the same looking formula, F and D, but the F and D stand for different things here. So
Yeah.
the D is the diameter and the F is both couples, both turning forces.
It's fun to write it is two equal but opposite forces F. It's only okay.
No, I need the whole box, please,
Okay.
for the exam. For the exam, yeah, you would need all of this. At least this for the exam, but really the whole thing.
So,
Okay.
one
Yeah. Have you seen this before in high school physics? Couple.
no.
No? It's a new idea, yeah?
Yes.
Oh, okay. All right. Continue?
No.
No?
Doesn't.
I'm going to move on now.
Okay.
Yeah? You can grab it from the video. Okay. Right. So, now, what's a cantilever? So these are examples of cantilevers. You've seen them in real life, you know. The first one is called a simple cantilever. That's when you just take the wood and you just stick it to the wall like this. The second is called a brace cantilever. So that's when you have something underneath helping it. And then the last one is also a brace cantilever, except you use a rope.
Like the table, like this part.
Yeah, but they're always against the wall. So, like for example, I'll show you here.
Like the door.
No, against the wall like this. So this is a simple cantilever. Then if you put something under it, that's a brace cantilever. Or if you put a rope here, that's a brace cantilever.
Up it or down.
From the top to the end. Yeah.
Or no, like I mean that you can put it from up or you can put it down.
Yeah, they're both braced. So braced is when you have something under or something above it. Okay? This is called a strut. Compressive strut or just strut. This is called a strut. And this is called a stay. Okay, you need to know these words. So this is simple, this is braced with a strut, and this is braced with a stay.
But the both have the same name.
Yeah, but this is braced with a strut,
Yes.
and this is braced with a stay. Okay, no, I'll give you a minute. I'd rather you write it down. It's more important. Okay.
Okay.
So, in fact, you could even draw these in your notebook.
Yes.
I think these are all new words. Yeah.
Yeah.
Stay, strut, and braced. Is that a new word as well? Braced.
Yes.
Yeah.
Yeah. Okay.
Like if you take the stay one,
Yeah.
the doors of the aeroplane.
Airplane doors.
Yeah. The of the helicopter. No, the one small one. They open like private jet.
Oh yes. Okay, that'd be like a stay then.
Yeah.
Braced with a stay. Yeah. And what would be something that's braced with a strut?
It's in the shipyards. Then when they are.
Oh, these are all fancy examples. Give me something simpler, like day-to-day life. Braced with a strut. Be like a bridge.
I've seen
A bridge.
yeah, bridge.
Bridge. Yeah.
Which bridge is there?
Any bridge. Most bridges. There's two types of bridges. You can have
There is the
braced with a strut. These are like the older bridges. But then the newer bridges will be braced with a stay.
Yeah.
Like the bridge on the river Thames is.
Yeah, the one in movies.
It's a stay. Yeah. Yeah. The Golden Gate Bridge, braced with a stay.
I saw a video that there is a bridge in the water.
Underwater.
Yes.
No, in the
like
water it's like between the water. There is a in China I think. In China.
Something like that.
There is a
Like
bridge
cars
which
are
crosses the sea.
moving.
Underwater.
No, not underwater.
On the water.
On the water.
Floats?
Above the water.
Floats. Well, all bridges are above the
No,
water.
in the
So what's
water.
so special about this one?
But it's like a sea crossing the sea.
Oh, okay. It's just a really long
Yeah,
bridge.
It's very long bridge and
Oh.
it's connecting another town.
Oh, okay, okay.
How long
okay.
is it?
Go, bridges all above.
I was wondering what was special about this one.
Like, there are some trains, the underground trains,
Yeah.
going through the water.
Yeah, like between England and France.
Yeah.
Underground tunnel.
It's inside the water.
Yeah.
How long does it take, or did it take to make that one?
Oh, that'd be a big project. That'd be like 5 to 10 years, I would have thought. Because you're digging under the earth, you know. So
Yeah,
like
there
that-
is a machine.
yeah, you've seen them. They're great. Yeah.
And the
They-
National Geographic.
yeah, they're great, aren't they? They're big, huge
Mega-
drills.
Yeah.
Megastructures. Yeah, that's it. Yeah. Okay, did you draw the three of these now?
No,
So anyways, I'll give the definition here. So, this is a cantilever. A cantilever is, now before I write down, the definition is very technical, okay? So don't worry if you don't understand all the words. A cantilever is a rigid structural element, such as a beam or a plate, anchored by only one end to usually vertical support from which it's protruding. Now, there's probably 10 words in there you don't know. So, what you can do is you can write it down, and maybe you can use your dictionary at home to try and look up some of these words. But I don't think there's anybody in this room that knows all of these words, except maybe me. Okay? So don't worry.
Rigid is like stay.
Rigid is solid.
Solid, yeah.
Yeah.
And structural elements such as a beam anchored at only one end. Placed.
Yeah, anchored's like
Yeah.
secured.
So we
Last
must
one
write
is
all of
difficult.
this
Protruding.
Protruding.
So we must write this.
Please write it down, yeah.
Okay.
You wrote all of this down? Okay. So, the three cantilevers, which is the worst cantilever? The first one is no good. It will easily break.
Yes.
The second and third one are better.
Yes.
But which is cheapest?
The first one.
No, the second or third one, which is cheaper? Probably the third one. So I think this is why most bridges are now like stay bridges. Yeah. Okay, continue?
Yeah.
Yeah. Right, so we have a couple of questions, I think. Yeah, we only have 2 questions to do, okay? So the first one, you can write it or you can draw the information, okay? So either write it or draw it, and then I'll do it. Okay, so write it or draw.
Better.
If you can draw, then draw.
The diameter is half or full?
I won't tell you. Not yet. Okay, so I'll draw it now. This is what it looks like. This is the steering wheel, and she has 5 newtons one way and 5 newtons the other way, and the distance here to here is 0.3 meters.
Yes.
So what is the couple? What is the turning force?
10.
Nope.
So 0.3 by 12 plus 10.
No, 0.75.
0. Point what?
75.
I don't think so.
Like 0.3. So will half. It will be half.
No. What is it?
Oh, it's D and
3? Yeah.
No.
0.3 multiplied by
1.5.
Finally. 1.5. Because
3 over 2, yes.
remember the formula? The formula was force multiplied diameter.
Yes.
So this multiplied by this.
You didn't even need to.
Does.
I did 10.
10.
0.3.
No.
2.
You,
Which is the same.
yeah, if you want to do it that way, it'd be 0.15. So what you should have done is 0.15 times 5 plus, and then this one,
Yeah.
0.15 times 5.
And then divided by 2.
Divided by 2? No,
That's it.
No,
That's it,
You
just this.
divided it by 2.
yeah. So you get the same answer if you do it the other way.
But it's way less.
Yeah. Okay. Let's have a look at the next example now, and then I think we'll do the next lesson, or at least get a start on it. Okay, continue.
Is the unit for Newton?
Newton meter.
Oh, Newton meter.
Again, you can write it or you can draw it. And I'll say this is a very important example because this is the one with the cantilever, and this is a braced cantilever with a stay.
Oh.
Okay.
You can draw it.
So draw it if you want, yeah. So what happens in this story is you have a sign and it's hanging on a cantilever, and the cantilever is braced with a stay. So it's like a shop sign. Yeah? Do you want to try and draw? Let's see what you draw. Try to draw it.
I think it was in the ESAP last week.
You did these last week?
No, we
Was
want
it?
Cantilever.
The sign.
Shop sign? Yeah, that sounds familiar.
Yeah.
Was it?
Pretty.
I don't know if it was a cantilever, but. Yeah.
Andy, any luck?
I cannot.
Oh.
It was like this.
Yeah.
Not bad.
Sign?
Not right.
Sign is right.
No? Let's see what you drew, Mir. No, not finished.
Not finished.
Not finished, yeah.
Confused
Yeah,
with the,
The sign?
No, not with the sign. Then number.
Oh?
Like it's 40 by 20, and then
Let's see what you drew. Yeah.
I draw the diagram.
Yes, that's it.
Huh?
I'll draw it now.
Oh, yes.
So you have, look, this is your sign for like the shop, and this here I said is 40 centimeters, and this here is 20 centimeters, yeah? And I said it's on a cantilever, and the cantilever is braced with a stay, so like here to here. And I said it's the stay is 40 centimeters up the wall, so that means here to here is 40 centimeters. Did I say how long this was?
No, I did it.
There is a mark also given. 2 kg.
Yeah, but hang on. Oh, sorry, I drew this a little bit wrong, I think. A 40 by 20 sign of mass 2 is hung by means of... The stay is attached 40 centimeters to the wall, and the other end is attached to the end of the cantilever. Sorry, I meant to make the shop sign equal to the whole thing here.
That's what we did.
Oh, good. Well, then you did it right. We'll call it Stephen's shop then.
Of course they were.
Steven.
Yeah. Okay. Right, so it looks like this. And what did I say the mass of the sign was?
2 kg.
2 kg. So there's a force down here of
2G.
2g. Good, okay. Okay, so this is what you should have then. Right. What was my first question? Yeah. So I didn't draw all my forces. I'm still missing some forces.
The reaction.
Yeah, well, let's do the easier one first with the stay. So there's a force here, and we'll call that force T. Okay? And also, there's a force here. What type of force is here? You said it, Iyad.
Reaction.
Reaction force, very good, yeah. Now, here's the big question for you. How should I draw this force? So look, can you all look? Wait, you have many choices, okay? You can draw it like this, or like this, or like this, or this. So which is the right one?
Maybe it's up.
Yeah, it could be up, yeah.
I think it's along
northeast.
It's like
I think you're right, it's northeast. I'll explain why. Because if you think about it, if I push here, then the wall pushes back. And if I push down, then the wall is pushing up. So this sign, okay, it wants to fall down. Right? It wants to fall down. So the wall is keeping it up. And also this wants to go left but the wall is pushing right. So the wall is pushing right, and the wall is pushing up. So together, they make this one. So this is the reaction. Now the problem is, you don't know this angle. Yeah, you don't know this. You do know this. Because you have this distance, and you have this distance. In fact, if this is 40, and this is 40, what's this angle?
80
No, 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 no. This is 40 centimeters. This is 40 centimeters. No.
30.
45. It's
He said it before
Yeah.
you. 45.
Why?
Why? When you have a triangle and two of the sides are equal. If this is the same as this angle is 45 and this one's
90.
40.
Okay.
And this one's also 40.
But look, even if you didn't know that, it would just be tan inverse 40 over 40. No, it'd be opposite over adjacent. Yeah. So it doesn't matter. Right, so this angle here is 45 degrees. We don't know this angle, we'll just call it theta. Huh? What's this? Theta. Alpha, beta, gamma, delta, theta.
Oh,
Yeah.
I know that.
I know, it looks like a Pokeball, but it's theta. Alright, if you don't like my theta, alpha.
Yeah.
Okay. Alpha better, right? Okay, so did you add this into your diagram? Yeah. So the first question is, what is the tension? What is the T? Okay. So, any ideas? What should I do first?
R divide T.
No? Does anyone have ideas on what I should do?
So it will be R divided 45.
No?
It's 45
The-
sine
Yeah, the first
sine
thing...
45 and then
Yes.
before
The first thing I should do is change this to T cos 45, and then this one here, T sine 45. And this one here will be or cos alpha, and this one here, or sine alpha.
Why we are using cos and sine?
I'm resolving.
Okay.
Remember this word, resolving? Yeah. Right, so now we'll make a turning point. Which is the best turning point to use?
the one
The blue one on the left.
There's many blue ones. Yeah. You're saying this one. Why? Why is this the best one to use?
The distance.
No?
no, because we are given the values on this side, we can with this.
Yeah, keep it simpler. Why is this the best one to use? We should use this one because we don't know alpha.
Yeah.
So we want to cancel these. We don't want these in our formula because we don't know the alpha. We can't know this. But we can know this one because we have the numbers. Yeah. So, this force, clockwise or anti-clockwise, using here?
It's
Clockwise.
Clockwise, and this one?
Anti.
Anti, and this one?
Which one?
This one on the ground?
Zero.
Correct, because it goes through the turning point. So we only have two turning forces. That's nice. The distance now. What is the distance from here to here? Because that's where this force is.
0.20
0.20. And the force?
for
This one?
2G.
2G. And that should equal, what's the next distance from here to here?
0.4
And then the force? T
equals 45.
sine.
Yeah.
Because this is the sine
Yeah.
one, and this one is the cos one. Can you know the T?
Yes.
It's very easy to get the T for this.
0.4 with 45, sine 45.
Yeah. So let's calculate it.
Okay. 0.4 plus sine 45. So I divided 0.2.
It's 13.87?
Yeah. Don't worry, we have it. 13.87. So this question looked very difficult, but when you properly draw it, it's not so difficult.
It's a
Yeah.
problem to draw it.
Yes.
Yeah.
Yes.
Like,
Because the question, like we
if this question comes in the exam,
They'll give you the picture in the exam.
Oh,
Yeah.
that's good.
Oh, yeah.
Yeah. Okay. The next part. The next one is I want to know what is the horizontal reaction force. So I want to know now what is this force, and then for part C, I want to know what is this force. Okay, who has any ideas on how to find these two?
Which two?
In the boxes, the or sine and the or cos. What should I use next? I'll tell you, look, simple. The up force equals the down force. So what forces are going up here?
R sine 45.
Or sine alpha
Alpha
plus,
plus R
Plus
cos,
30.
no, t
T
sine
sine
45, that should equal
0.22 G.
2g.
Okay, why it's okay, 2G
Yeah.
inside bracket.
Huh?
No.
2G.
2g, yes, you got?
2G.
Yeah. So then we get or sine alpha equals 2g minus, now do we know t?
Yeah, 13.87.
Yeah, 13.87 sine 45, so this will equal,
It will be easy.
yeah, what have we got here?
One second, so 13.
I got
9.81.
9.81 newtons. Now how can I get the horizontal? What can I say for the horizontal? I could say or cos alpha should equal
Equal 45.
t cos 45. The force to the right should equal the force to the left. So t, what did I say? No, or cos alpha should equal t cos 45, which equals 13.87 cos 45, which is also 9.81 newtons by coincidence. So, just so you're clear, how did I get this equation? I said the clockwise equals, sorry, that's the anti-clockwise equals the clockwise. How did I get this equation? I said the up forces equal the down forces, and how did I get this one? The left forces equal the right forces. So can you see, in all these questions I'm doing, I'm using the same idea. Okay, there's one part left to this. Okay, the last part is, what is the magnitude and direction of the reaction force? So that force here. So let me put it down here. Here's the wall. And then we have, here's my shop sign. And how much did we say this was? This one was 9.81. And this one here, we said was 9.81. So I want to know how big is this and what's this angle. So this is Pythagoras.
Okay.
9.81 squared plus 9.81
Squared.
squared equals r squared. What did you get?
13.9.
13.9 newtons. And then the theta is, sorry, the alpha
Oh,
is tan inverse 9.81 over 9.81, which is 45 degrees on your calculator. So this is the reaction force in total, and this is its angle here.
so the answer is 45.
And 13.9. Because I asked you for the magnitude
Yes.
and the direction.
No, I'm talking about the tan inverse.
Oh yeah, that's 45, yeah.
Okay, for the 9.81.
It
It was 13.9, yeah.
No,
is it
no.
rule to find R you have to
Yeah, it's a rule. And I think you remember, what's the name of this rule? To find the or? Come on, it's our friend, begins with a P. Pythagoras, yeah. Yeah, do you know this guy? Pythagoras. Or if I say it in Arabic, Pythagoras.
Eta.
Yes. You know this guy?
yes.
What was the
square root of
Yeah,
9.81 squared plus 9.81 squared.
yeah.
Did you convert that?
Ah!
Converter?
English.
Yes.
Okay. Right, did you write this down?
Yes,
Yeah.
but I'm talking about the 9.81.
This?
The rest, yeah, how it gave us 45.
Did you type this in on your calculator?
Yeah,
Now-
I got does not answer.
Yeah, because I told you
Been a month.
this one.
Under a month.
Okay,
I
use
know,
this
I
one.
don't know from where to get it.
Amazon, eBay, Argos, Eason's. In the city centre, go to Eason's. Yeah,
Okay.
you'll find it. It's not that everybody else has one, don't you? Yeah.
Oh, I got it, I'm sorry.
Okay, right. Right, can I continue?
Yes.
Yeah, okay. So, okay, I think you found that a little bit difficult. So, okay. Do I want to start the next lesson? No, I'd rather you do this. What I want to do is I want you to do this, but I want to check if you can do it before you go. So, what I would really like you to do now is question 1 and 2, and then we can leave 3 and 4 as homework. Okay? So if you can do 1 and 2 now, and if you get stuck I can help you. But you have 10 minutes. That's plenty of time to get 1 and 2 finished.